I added, okay, there we are, BC Calc. I don't know if my face was on that last video. I figure it doesn't matter. You could see the screen that I was working on. I've changed an extension in Chrome to handle having you guys meet in breakout rooms. And that's pretty cool. I'm looking forward to doing that. But unfortunately, it slightly changed the look and feel of how the software shows up on my screen. Okay, so here we are, section 5.4.2. I'm just going through a section of notes here. So this problem is asking us to evaluate g prime of -4. Okay, so now all of a sudden this stuff steps up and it gets real. Okay, so here's the deal. Getting back to here, when you see g of x is equal to the integral from -3 to x of f of t dt, because this is a constant and because these match, I'm just copying this down onto my paper here. G of x is equal, here, let's show you. G of x is the integral from -3 to x of f of t dt, okay? Because this is a constant, that's the anchor, and because these match up here, okay, that tells me g is the integral of f. In other words, f is the antiderivative of g. And so what I'm basically saying is g of x is what we were calling that capital F of x, that capital function, the antiderivative of this. And don't get hung up on why did I change this t to an x. Remember, it's a dummy variable. Okay, this could be any variable I want. I just can't use x because x is the upper bound. So what we're saying is g is the antiderivative of f. And so if you ask me now to take the derivative of g, that would by definition be the derivative of capital F of x. But the way we define that, that has to just be plain old f of x. Okay, and so when you see a question like this, therefore, g prime of -4 must be equal to capital F prime of -4. And we don't really know or care what that is. What matters to us is that that is simply f of -4. Okay, and so now if you just follow the algebra where it leads you, it's telling us just evaluate function f at -4. Well, look at the graph. What is f of -4? Well, here's 0, 1, 2, 3, 4. F of -4, 1, 2, 3, 4 is right here. So what is the value of f at -4? Well, just from the graph, that equals 0. Okay, and so f of -4 equals 0. Okay, and something to think about here. This is a derivative, right? G prime of -4 is 0. And so what this means is we have a horizontal tangent on the graph of g at -4 because its derivative is 0. Okay, so keep that kind of thing in mind. That little tidbit is going to help you a lot in this class and understanding what's going on here. Okay, then it says evaluate g double prime of -4. Okay, and so we kind of get freaked out by that and we go, oh my goodness, I have no idea what that is. But let's relax and back up a step, right? We know that when these fit this pattern, when this lower bound is a constant and the upper bound matches and it just says x in both places, x there and x there, in that case, we can say, okay, well, g of x is simply the integral of this lowercase f of x. So that would be capital F of x, like so. Okay, so let's just use the definitions from calculus of what this all means. If I take the first derivative, that would have to be the first derivative of capital F of x. But by definition, the first derivative of capital F of x would be plain old f of x. And so when it says g double prime of -4, well, by definition, the second derivative of x would be the second derivative of what we call capital F of x, which would be the first derivative of f of x. So we end up with g double prime of x is simply f prime of x. Okay, and that's just going to be true every time we have a problem where this is a constant and these two match. Always that way. Okay, so now it's just a question of evaluating. Just plug the numbers in and see where it leads us. G double prime of -4 is equal to f prime of -4. So if I can figure out what f prime of -4 is, then I'm fine. But think about what that notation means. It's saying take function f, go to -4 on the x-axis, and figure out the slope of the tangent line there. So let's look at our graph here. Let's go to -4, 1, 2, 3, 4. I'm at this point. It is asking me, well, what's the slope there at that point? Well, let's see. We know that this is on a line segment, and so the slope of this, I simply do rise over run. So I'm going to do the change in y. That would be okay. You can't see both at the same time. What I'm going to do is I'm going to do 2 minus -4. That's the change in y over -3 minus -6. Some of you will look at it more simply and say, look, dude, rise 4, run 2, positive slope. Okay. But I generally like to just document what I'm doing here. 2 minus -4. I subtracted the y's over -3 minus -6, like so. Okay. And that becomes g double prime of -4 is equal to this becomes 2 plus 4. This becomes -3 plus 6. And this is equal to 6 over 3, which is just a slope of +2. And so there is my answer. I just end up with a slope of +2. Okay. And so looking at this, I suppose I did use a sledgehammer to kill an ant there. Now that I look at it again, this is a rise of 2 and this is a rise of 1. I should have pretty easily been able to calculate that that's a slope of 2 there. Instead, I went for the sledgehammer. I did this entire thing divided by this entire thing. This entire is 6. That's 3. 6 divided by 3 is 2. Or I could have done 4 over 2. And either way, the point is you end up getting the slope of 2. Okay. All right. And then finally, it says specify all of the points of all of the coordinates where G has a relative minimum. Wow. Okay. So they're stepping it up here. Okay. And now they don't tell you this on the test. Okay. On your calc test, they're not going to tell you that. They're just going to say, where does G have a relative minimum? An appropriately labeled sign diagram will help to justify your work. Okay. So something we need to recognize here is that it tells us that f is defined on this interval. So f is a continuous function. One issue that's going to come up, though, is that the second derivative of g, that is the derivative of this, is undefined in some spots, which can make our analysis a little tough. Whenever it asks for where are the relative minimums of this graph, what I do is I always go for g prime of x, and I look at its sign. It is G increasing, is G decreasing, and so on. And fortunately, I've already done a lot of algebra ahead of time and figured this out, that G prime of x is simply f of x. And so what I'm going to do is I'm just going to make a sign diagram for it. Okay, so where is f of x equal to 0? Well, look at the graph. Okay, this is the graph of f. Where does f of x equal 0? It happens at -1, 2, at -4, at 0, and at 6. Okay, so f hits 0 at -4, 0, and 6. So at -4, 0, and 6. Okay, and then I want to be careful here. Actually, 6 is my end point there. So I need to be careful. I don't want to signify that that's actually equal to 0. Oh, no, it does equal 0 at that endpoint. I take that back. It does equal 0 at that endpoint of 6. Okay, I need to label that that's my endpoint there. Okay, that's my endpoint of my interval. And the other endpoint down here is at -6. And I just want to be really clear about that I'm at this other endpoint at -6. That's an endpoint. And I want to be careful that I'm not saying on my sign diagram that the slope is 0 there, because it's the f of x does not equal 0 there. Okay, so then the next thing is to just look at the sign of f between -6 and -4. This is below, so it takes on a negative value. So f of x is negative between -6 and -4. Okay, and that would have to be the derivative of this function g. Okay, but just focus here. The derivative of g must equal f of x. So f of x, I'm saying, is negative between -6 and 4. Look at the graph. Between -6 and -4, this is below the x-axis. Therefore, those take on negative values. Okay. All right. The next interval goes from -4 to 0. And between -4 and 0, f of x, this graph here, is positive. So I'm going to put that on here as a positive, like so. Okay. And then finally, between 0 and 6, f is below the x-axis. So f itself takes on negative values in there, like so. Okay. And then this really doesn't belong on here. The function does not exist past 6. Okay, so the question says, where do I have a relative minimum? Well, now it's just a matter of looking at this. G, the derivative, is negative here, so it's decreasing. Then it hits 0, then it's increasing. So that right there is a relative minimum. Okay, and then G is increasing. The derivative is positive, so it's increasing, and then it switches and it becomes negative. Okay, so that's a relative max. Okay, so it says specify the coordinates of all points on this interval where G has a relative minimum. So G has a relative minimum at -4, comma, and then we need to evaluate G of -4, okay? Because it asks for the coordinates of where that happens, okay? And so I need to do a little bit of work. I need to calculate G of -4, okay? And so let's take a look in here. I haven't already evaluated that. I have G double prime of -4, and I have G prime of -4. Remember, we said that was 0. I talked about that, but I didn't evaluate that anywhere. And so I'm going to do some work up here for H. It's nice to be able to look at this picture. So for part H, I need to calculate G of -4. Okay, and so I'm just going to use the definition they gave me to figure this out. By definition, that would be the integral from -3 to -4 of f of t dt. Okay, well, notice I'm going from -3 to -4. I'm going backwards. Okay, I'm going backwards. And so that is the opposite of whatever area I get here, because this is above the x-axis. So this area here, I need to do the opposite of it. And so I need to do the opposite of that area right there. The area of that triangle is 1/2 base times height. Its base is 1, its height is 2. And so that equals -1. Okay, so I have that issue to contend with. So I have a relative minimum at -4, G of -4, which is -4, comma, -1. Okay, now something else I need to consider is these endpoints here. Okay, all right, darn, I'm running out of room. I guess I can squeeze this in here. Okay, this at this left endpoint, the function is decreasing. So at that endpoint, the function is decreasing. So that would be a relative max there. This point here is a relative max. Okay, and then here, this endpoint here, the function is decreasing as I hit my right endpoint. Okay, so that is a relative min also. At 6, I have a relative min as well. Okay, and so I have one there. I also have one at 6. Okay, and at 6, comma, and then I need to evaluate G of 6. Okay, so what I think I'm going to do, I'm probably going to have to reformat these notes so you guys have a little more room to work, to actually do this work. Okay, all right, and so here I am. I'm looking for a Post-it note to put the rest of the things on. Of course, my desk is always covered in paper until a minute when I need to add a little bit of extra notes here. Okay, so here we are, little piece of scratch paper. So I need to be concerned with G of 6. So by definition, G of 6, well, what does that equal? Okay, so I look up here. G of 6, according to this definition, is the integral from -3 to 6 of f of t dt. Okay, so I just need to evaluate the area going from -3 to 6. That's all I need to do. Well, fortunately, I've already evaluated this from -3 to 0. And so what I'm going to do is I'm going to break this down into pieces. I'm going to integrate from -3 to 0 f of t dt, just to make my life easier. You don't have to do it this way. You can just add all these areas together, add this one, subtract those. But I've already evaluated this one, plus the integral from 0 to 6 of f of t dt. So this is just one way of going about dealing with this, okay? So G of 6 would be equal to this area. Well, I've already worked that one out. I already did that here. The integral from -3 to 0, I've already evaluated that as 5. Okay, and so then it says plus, now I have to evaluate this area from 0 to 6. Okay, so notice these are all negative contributions of area because I'm going from 0 to 6. So let's see, let's break it down into a triangle there. Okay, that would be, so that's 5. I'm going to do -1/2 of its base times its height, 1 times 2. Okay. Some students prefer to say plus and make the height negative, which is also fine. All right, and then I need to subtract this area here. So that would be minus, okay, the area of a trapezoid is the average of its bases. So this is down 2, and this is down 3. So the average of its bases is negative 2.5, or 5/2. That's the average of its bases times its height, which would be 2. Like so, okay? And then finally, I have this triangle here whose base is 3 and whose height is 3. So minus 1/2 of 3 times 3. And so I'm using my knowledge of geometry to answer this calculus question here, okay? So let me see about this. There's part of me that's thinking I made a mistake here. This area, let's see, it was 4. Yep, and then one more here. Okay, that sounds right. Okay, so g of 6 is equal to 5 minus 1, and then minus another 5, and then minus 9/2 there. Okay, so let's see. I end up with g of 6 is equal to the 5's go out. So negative 1 minus 9/2, or negative 2/2 minus 9/2, negative 11/2. Okay, so I end up with g of 6 is equal to negative 11/2. Okay, so all right, there's a bunch of extra notes there that I really kind of needed to answer this question. So we end up with the second relative minimum at 6 negative 11/2, like so. Okay, and I'm sorry that that's kind of crammed in there like that, but there we have it. The G has a relative minimum at -4, -1, and at 6 negative 11/2. So there are the 2 points where I end up with a minimum. Okay. All righty, guys. I'm going to catch you guys at the next video. Okay. I will see you there. Okay. All right. Bye-bye.